Hi everyone, and welcome to lesson 32.3. Today's lesson is starting on page 450 in your books. Now on page 450, we are back looking at this robotic arm that's talking about our directional angle. And we've talked about how the magnitude of the new resultant vector that we found from adding them together is different than finding the individual magnitudes of vector u and vector v and adding those together. You have to first find that resultant vector u plus v, which we know is 18.3, and using that value to find our resulting magnitude. So we would take 18 squared plus 3 squared, and we know that the square root of that's about 18.2. And then to find the direction, we know we're using tan inverse, and it would be the b value divided by the a value. So in this case, tan inverse would be not about 9.4 degrees. And since this was a positive direction, quadrant 1, 9.4 is our final answer then for that direction. Now, looking at some other examples, however, we want to be aware again of our direction. It's a good time to be careful of the direction of our graph. So if we notice this graph is the scale on these are going up by 2s. We actually are going to the left 4 and up 8 for a resulting vector of -4, 8 in our component form. Now, in order to find them the magnitude, again, your magnitude is always going to be found by taking that square root. Now, reminder when you're typing in parentheses to be careful that you are properly squaring these values, that when you're typing them in, you are typing it in with parentheses so that the order of operations is correct. If there's a negative value, so we get about 8.9 there. And then we have to be careful because this time, notice the direction of our arrow. This is facing quadrant 2. So you have to be careful on the degrees on this because for the direction, when we take tan inverse of b divided by a, what we're going to notice is we're going to have to be a little cautious of that final answer. Because we see that -63 degrees, that's officially actually a quadrant 4 value, right? And we know we're going up and to the left. So we would need to add 180 degrees to this to get that final answer of 116.6 degrees. Okay, so again, be aware of the final answer here needing to result in a second quadrant value, or second quadrant value. Now, while officially our vector is somewhere in between quadrant 1 and quadrant 2, again, you want to think directionally. If we had shifted this down, it would be quadrant 3 directionally, right? It's between 180 and 270 degrees if we think of it in that respect. So when looking at this example here for part B, again, be careful when it comes to your direction. Again, our scale is going up by 2s, so we went from tail to head, we went to the left 6 and down 6 for a total magnitude of -6 squared plus -6 squared. So the square root of 36 plus 36, because both of those negative squared is positive, is about 8.5 roughly. And then the direction, again, you're going to have to be careful because when you try taking tan inverse of both of these negatives, it's going to actually give you a quadrant 1 value. But again, we know that we're between 180 and 270. So again, be careful, make sure you're adding 180 degrees to get that total direction of 225 degrees. Okay, so again, for your reference, realize that even though this gave you 45 degrees, you need to add 180 to that theta value, and really you're 225, which would directionally show the proper location for an arrow pointing down and to the left. Now, skipping ahead a little bit then, talking about some of these other examples, briefly. Again, the component form we've kind of been talking about using above, so I'm going to skip this example for a moment, have you do that on your own. And then a reminder, in order to complete Part D, you will need to also find the component form first, and then find your resulting magnitude and direction. Now, when we are resolving a vector into component forms given the direction and the magnitude, so kind of going the opposite way, to find our A and B components, it's very similar to when we talked back earlier in Unit 5 about polars and finding the x and the y given r and theta. It's kind of that same idea that to find A and B, you're multiplying the magnitude by the cosine of the angle, and to get B, you are multiplying the magnitude by the sine of our angle. So essentially, A is equaling your magnitude of your vector times cos theta, and then B is the magnitude of the vector times the sine of your angle measure. So it's kind of the exact opposite of what we were talking about above. Now, obviously, exact values are great if you could find them when we have directional angles that are from our unit circle. So just notice they simplified there to put those into our component form. The same thing can be done with Part A because 225 is a value from the unit circle. So in order to find component A, we are going to take magnitude times the cosine of 225. And to find component B, we would take the magnitude times the sine of 225. And in this case, we would have 8 times negative square root of 2 over 2. Same thing actually for the sine. That's the sine of 225 is also negative square root of 2 over 2. So we have negative 4 square root of 2, negative 4 square root of 2. Final answer written in that bracketed format. There will be a component form. Now, obviously, we sometimes will have angle measures that are not from our unit circle, from, for example, example D, or even if you're just rounding. Again, I'm not being too particular at this time, but for example, on this one, our magnitude, our length here is 22, and then obviously the angle measure is negative 20 degrees. Again, make sure that your calculator is in degree mode, as it should already be. We have 22 cosine of negative 20 degrees. And obviously, I'm just going to jump ahead as well with the sine of negative 20 degrees to get our A and our B format on this one. So you can have just the rounded answer, since negative 20 isn't going to give us an exact answer. We would see 20.673, negative 7.524. Okay. Now, this makes sense because negative 20, obviously, especially looking at this picture, think fourth quadrant value, it makes sense that, our vectors moving to the right and down, to see that visually, that this component form makes sense that you would go 20.7 and negative 7.5. It makes sense to see that resulting vector. And so that's why I like example C and D, because you can kind of see that visually. Now, as we move on then, the last piece of this is going to be coming from talking about then when we are adding and subtracting and doing different operations with our vectors, how to find that component form. So kind of going back to what we talked about initially here, in order to find the magnitude and the direction of this robot arm, we had to find the component form of u plus v first, and then use that value of 18.3 to compute the magnitude and the direction. It's kind of that same idea with example B. We're given, this magnitude and direction of initial vectors, v and u. And if we want to add them together and then find the magnitude and direction of that resulting vector, essentially we have to find the component forms of the two original vectors, and then add those together, complete this operation, actually add the two resulting vectors together, and then finally you are able to find the magnitude and the direction of that. Okay, so this is the bulk of as complicated as today is getting for sure, and they do not give you a ton of room to write, so make sure that you are using the My Notes section or maybe down some space in number 5 as well. We're not going to do that, so you can kind of see. Okay. Now, for this example here, they're giving us two different vectors, right? Vector S and vector T. Okay, so I'm going to start by writing these out. We have vector S and vector T and finding the component forms of these two. So the magnitude of S is 10 and its directional angle is 125. So component A is going to be 10 times the cosine of 125, and B is going to be 10 times the sine of 125, while T is at 15, negative 15, oops, so 15 cosine of negative 15 degrees, and then 15 times the sine of negative 15 degrees. Okay, so we have those kind of approximations, if you type them in your calculator, if you will, for both of those kind of things. Okay, so as we're calculating S minus T, and we eventually want to find the magnitude and direction, the first thing we need to do is actually calculate, okay, what is the value of S minus T? So you can take, again, to find component A, we're going to end up subtracting the A component of S, which we know is 10 cosine 125, and we're going to subtract away from that the A component of T, which is 15 cos negative 15. And then for component B of this, we have to take the two B components of S and T, 10 sine of 125, and we're going to subtract away from that 15 sine of negative 15 degrees. Okay, so in order to find our component form, again, we're going to start 10 cosine 125 minus 15 cosine negative 15. The A component is approximately negative 20.2. And for our B component, it's the exact same thing. So I'm going to hit second enter to get just this pulled back up. The only thing that is changing here is that this is now going to be a sine, and this will also now be a sine. So our B component of our new resultant vector is 12.1. Okay, so S minus T is negative 20.225. If we're rounding a couple decimal places, you can round to the nearest tenth, and then 12.074, 12.1 works as well. Okay. Now, this is our component form. So in order to find the magnitude of this new resulting vector, we're going to take the square root of negative 20.225 squared plus 12.074 quantity squared, for a total of about 23.5. And then when we look at cosine inverse, or excuse me, tangent inverse on this one, we have 12.074 divided by A, negative 20.225. And we see that our value is negative 30 degrees. Well, think about, again, location, location, location. You're going to the left and up. So your arrow is really going in the direction that's a quadrant 2 value, aka between 90 and 180 degrees. So even though the theta value is coming out to be negative 30.837 degrees, really we know that based on the location, our actual theta value, we're going to have to add 180 degrees to this to get it to be in the appropriate quadrant. So we would be at 149-ish instead. Okay, so your final two answers there would be the magnitude, and then of course 149 degrees is the direction. Okay. Let's try one more of these. And that one is we'll look at example C here. Now, from up above, we said that we have vector S, right? One thing we didn't calculate, though, was 2 times, vector T. Just need the T with the arrow. And if we doubled the 2t, really instead of being just 15, if we double this, it would be 30, but our angle measures would stay the same. So 2t is actually going to be taking 30 times the cosine of negative 15 degrees and 30 times the sine of negative 15 degrees. And then we said from up above, vector s was 10 cos 125 and 10 sine of 125. Okay. So in this case, if we want to find just the component form of 2t minus s, what we're going to have to do is take a minus a, and then b is going to be b minus b. All right, so typing all of this in, we have 10 cosine of, oops, excuse me, not 10, 30 cosine of negative 15 minus 10 cosine 125. The parameter A is about 34.7. And then same thing, 30 sine of negative 15 minus 10 sine of 125 is about negative 15, negative 16 really, right? So we have, we'll just round to the nearest tenth this time, 34.7 and then negative 16. And then again, to figure out your magnitude and your direction, now that you have the component form of this, you have the ability to find your magnitude. Negative 16. You should get 38.2. And then your direction on this one, again, be careful. As you look at the inverse on this one, negative 16 divided by 34.7, you have negative 24, and you want to double check, does that theta value make sense? Because if you have negative 24.8, well, if we're going to the right 34 and down 16, this is a quadrant 4 vector. Okay, so negative 24.8 degrees does check out this time. Obviously, you are able, though, to, if you want to be between 0 and 360, since oftentimes you'll see it that way. Remember coterminal, 335.2 also would be an acceptable answer, since that's another quadrant 4 value. Either way, that's officially a directional value that works, and then, of course, that magnitude of 38.2. Okay, so obviously a lot of information happening here. We will definitely be working more with these in class and on adult math. Thanks for watching.